Okay, anyone please respond. Can you hear me?
Can.
Yeah. Okay, and then can see the textbook,
Can.
Okay. Before that, maybe I show you this. Chapter 2, chapter 4. Excuse me. Excuse me. Okay, maybe we revise a little bit. This is what we have learned yesterday. So, okay, first of all, okay, look at this, the example of the rational number, okay, in form of recurring decimal. Okay, so this is a rational number, okay, and then the recurring decimal. Okay, second example, okay, this is a example of a rational number, but this is a terminating decimal. Okay, means not that type of infinite decimal. Okay, so all these are decimal, we call it terminating decimal or a rational number. Okay, and we continue the third type of example. Okay, example of irrational number. Okay, this is a not rational number, irrational number. Okay, then they are in form of a infinite decimal and non-recurring. Okay, infinite decimal and non-recurring. Okay, this type of decimal is an irrational number. Okay, so we start from the first one is a square root of 2. Okay, pi and the exponent. Okay, so the pi and exponent is under irrational number, not surd. Okay, and then the rest will be surd number. Okay, so this is for what we have learned yesterday. Okay, and then I give you the exercise, a few questions only. I hope you have finished. Okay, then we continue today. Okay, this one. Okay, convert the following recurring decimal to fractions. Okay, so this one, you will learn in this, now we are in chapter 4. You're going to learn this again when you are in the topic of progressions, under geometry progressions. Okay, you're going to use another method to get the answer. Okay, so how to change a recurring decimal to fractions. Okay, so here you are using this method, then afterwards in another topic you are going to use another methods. Okay, so if come out in the exam and then they didn't mention which methods, then you just use either methods. Okay, let us start. Okay, we start with this. The first example, 0.676767. Okay, so the one we're repeating is the 6, 7. Okay, so you see the step is, okay, you let this 0.67, the questions be n, okay, or any other unknown. Okay, then the second step, you see this the blue color box. Okay, multiply with a suitable integer so that the part with the recurring decimal can be eliminated. Okay, what is this, the suitable integer? What is the meaning of here, the suitable integer? Okay, now the problem is how do we find this suitable integer? Okay, so you see here, okay, if these two digits are repeating, okay, so the suitable integer actually is the 100, means with 1 and then 2 0. Okay, if two digits repeating, then it's 2 0. Okay, so when you times 100, okay, to both sides, okay, so when you times 100 to n, you get 100n. When you times 100 to 0.676767, the decimal go to the right 1 2. Therefore, you get 67.676767. Okay, why you need to do this? The purpose is they want to eliminate the decimal. Mean after the dot, after the decimal point, this part they want to eliminate it. Okay, how? Okay, by using the second equations minus the first equations. So the left hand side, second equation minus the first equation, 100n minus n, you get 99n. Okay, the right hand side, 67.676767, you minus 0.67677, you get 67. Now you see when you reach here, you don't see anymore the recurring decimal. Okay, then last step, okay, n is equal to 67 over 99. This one times move to this side, become divide. Okay, what is n? N is your original question, sir. Okay, 0.67677. So now what is n now? Okay, the n now is a 67 over 99. Therefore, you can make these conclusions. The 0.676767 is equal to 67 over 99. Okay, we look at another example. Okay, the second example. Okay, you have a 12.645645. This 12 is try to disturb you only. Okay, the one repeating is here, the 645, 645, and the 645. Okay, so here 1, 2, 3, 3 digits are repeating. Therefore, you got to times with 1000. Okay, this is how you determine what is that suitable integer that you need to multiply with. Okay, so first of all, you got to take out that 12 that disturbing you one. Okay, so you let this be a A. Okay, therefore your A is the 12 plus the one recurring. Okay, so same thing, your n again is the one 0.645645, the one with a recurring decimal. Okay, then as I said just now, this is three digits are repeating, so you got to times with 1000, 30 here. Okay, then repeat the same step. Okay, so here when you times with 1000, okay, the decimal will go to the right, 1, 2, 3. Okay, therefore you get 645.645, and continue. Okay, then do the same thing, second equation minus the first equations. Okay, so 1000n minus n, you get 999n. Okay, and then 645.645 minus 0.645, you get 645. Okay, move the 999 to this side, become divide. Then you get 645 over 999. After that, simplify it, you get 215 over 333. Okay, this is for n. Okay, don't forget your actually your original question with the 12. So got to add with the 12. Okay, therefore this is your final answer. Okay, 12, 215 over 333. Okay, digest a little bit. Any questions you want to ask? Okay, if no question, we go to the side. Okay, look at this. Okay, convert the following fraction to a recurring decimal. How to do this? Okay, just now you have learned from recurring decimal to fraction. Now the other way around. Okay, from a fraction, how to get a recurring decimal? Is either you want to do this way, back. If not, then you do our normal way will be long divisions. Okay, so means what? Long divisions is a 224 divided by 495. Okay, you do long divisions. Okay, if not, then you have to try. You know, I didn't try it before lah. Okay, work back from here. Okay. Okay. So this one you may try it. Okay. Okay. Now look at this. Okay, the question is this. This one maybe you can write in your notes. Okay, is this, how to read this already? Surd A or the N? Okay, is this surd A or the N is equal to N times the square root of A? Okay, so they want to prove it okay, by using just substituting a number. Okay, let's say the A is 9. Okay, so square root of 9 you get 3. Okay, then N is 2. Okay, so now they want to prove whether, you know, this is a 2. 2 means square root lah. Okay, A is 9, and then the other one is 2 times square root of 9. Definitely it's not law. Okay, so you see this one is 3 times 2, this is 6, that this is 3, so this is not equal law. Okay, so remember this is not equal. You can write in your notes. Okay, this one I think done before. Okay, yesterday. Okay, this one the same thing. Yeah, if the question asks you this is just now, this example, same thing, same like just now. Okay, so how to explain it? Yeah, you just prove it, okay, left hand side and right hand side are not equal, okay, this one nothing. Okay, so today you can do this exercise. Today is what? 5th. Okay, this is yesterday. This is a 4th. Okay, maybe we go through a while. Okay, you see this? Okay, maybe you have to you can tell me what to times, what to multiply. Okay, let me call. Yesterday. Okay, Critinia today here?
Yes, teacher.
Okay, come. Where's my questions? Okay, you look at these questions. 0.787878. Okay, tell me what is that suitable integer to multiply with? Critinia?
100, teacher.
Yeah, okay, 100. Okay, so this one you got to times 100. Okay, and then the next questions. Okay, is Izati here? I don't know what's wrong with my... When I go to the list, I can't see the list. I don't know why. I can't scroll down and see the list. Why? Okay, can someone help me to see the list? Is Zati here?
Teacher, no. She's not here.
Oh, she's not here. Janice, what is her problem? Okay, better don't know her problem lah. Tired with her problem lah. Okay, Siva here. She didn't say. I think she didn't. She can't wake up. Oh, okay, Siva here. Can you please help me to check? Anyone? Siva in this group or not? I know it's only like 27 here only, so it's 3 girls not here. Izati is one of them. I don't know who is the other 2.
Teacher, I don't think she's here. Wait, let me check.
Because I cannot go down my list. I don't know why.
Not
You're
here.
just not here, huh? Okay, then we go to next girl. Sophie here. Sophie Lee.
Sophie also not here.
Oh, okay. So I think I spot the 3 girls already lah, huh? Okay, next girl is Suchitra.
Yes, teacher.
Suchitra.
Yes.
Okay, come. You look at these questions. Okay, answer my questions. Okay, next question is 3.57575757. Okay. Something is the disturbing for you to get the fractions. Okay, you got to separate out. What is that?
3.
Okay, 3. Okay, then after that, after you separate out the 3, you left a 0.57575757. Okay, tell me what is the suitable integer to multiply with?
100.
Huh?
100.
Okay, 100. Okay, so remember, separate out the 3. Okay, after that, okay, this one times with 100. Okay, next girl. Okay, Cheryl.
Yes.
Okay, come, you look at these questions. 0.345, 345, 345. Okay, what to time with?
1,000.
Okay, 1,000. Okay, next go. Rarely. Okay, so rarely you look at these questions. First of all, you got to separate that number from a recurring decimal. What to separate out? Okay, separate the 13, okay, and then with the 0.57. No, it's a 567, no? Okay, so you separate 13 and then 0.567. Okay, after that, the 0.567, what do you have to multiply? Okay, multiply by 1,000. Okay, thank you. Okay, this one multiply by 1,000. Okay, so I think you can do it. Okay, so we go to the next subtopic. Okay, so the index for today, you write this. Today is 5th. Okay, this one actually I think you have learned it lower form lah. If you have a square root a times a square root b, okay, you are getting a square root and then inside is a times b. Okay, then the other one is when you have a square root a divided by square root b, same thing. Okay, you are getting a square root and then inside is a divided by b. Okay, so this one you may copy. Okay, this is what you have learned I think during lower form. Okay, but very fast lah, huh? We just look at this software. Okay. Okay, we want to look at law number one. Law number one is the multiplier, huh? Okay, so this is the law number one. Okay, so this they design it in the way that you can control the value of the A and control the value of the B. Okay, so you see when I drag the A, okay, you see the number also difference. Okay, so this one is means square root of 9 times square root of 1, then you get square root of 9. Okay, how you get the 9 here is by 9 times 1. Okay, if I move, I change this the value of the B. Okay, the same thing. Okay, so square root of 9 times square root of 6. Okay, so you are getting 9 times 6 is 54. Square root of 54. Okay, this is law number one. Okay, how about we go to law number two? Okay, law number two, the same thing. Okay, if divide, then is the square root, and then the whole thing inside also is divide lah. Okay, so this is all about it. Okay, and then we come back to this one, the textbook. Okay, one more thing I want you to write down in your notes is this one. Okay, square root of A times square root of A. Okay, then you are getting a square root of A squared. Okay, the square and the square root you can cancel off, so you get A. This one, okay, this one is a third. 1, 2, the third one you need to copy in your notes. Okay, next we see how we apply these two law. Okay, to simplify the surd. Okay, write the following as a single surd. Single surd means only one surd. Okay, if this one is a two surd, okay, they don't want two surd, they want one surd only, single surd. Okay, so we use the first law. Okay, for this one. Okay, so square root A times the square root of B. Okay, you get the square root, and then inside is A times B. So 2 times 7, you get a square root of 14. Okay, look at B. Okay, this one using law number 2. Okay, square root of 24 divided by square root of 8. So you are getting the square root, the whole thing, and then the inside is 24 divided by 8. Okay, whatever you can simplify it. So you get 3. Therefore, final answer is square root of 3. Okay, look at C. Okay, the whole thing here, 3A and the 5A. Okay, inside you times. So you get 15A squared. Okay, square root of 15. This one nothing you can do. Okay, but square root of the A squared. Okay, this one you are getting A. Okay, therefore you write the A outside the square root. Okay, after simplifying. Okay, this one, same thing. Okay, you put a big square root, and then inside is 21A over 7A. Okay, whatever you can simplify it. Okay, divide by 7, you get 3. Okay, therefore the answer is square root of 3. Okay, I think this one is quite easy. So this one also your homework for today. Okay, look at this. Simplifying expression in involving surd. Okay. Same thing. We see a while for this one. Okay, you can go through one by one actually. Okay, I can start from a very beginning. Okay, square root of 1. Okay, whatever you can simplify it. Okay, square root of 1 is 1. Okay, square root of 2 cannot be simplified, so your answer is remain as square root of 2. Square root of 3, the same thing, cannot simplify. Square root of 4 is 2. Square root of 5 cannot simplify. Square root of 6 cannot simplify. 7 cannot simplify. Square root of 8. Okay, how to simplify the square root of 8? Okay, so that you can get 2 square root of 2. Okay, this is what we're going to learn afterwards lah. Okay, so you see, Okay. Always when you have this number, you got to think of all your perfect square. Okay, still remember what is perfect square? Okay, start over again from the first girl. Emmeline. Emmeline here. Emmeline. Hello, Emmeline. Okay. Perfect square. Can you list out perfect square for me? List out maybe the first 5 of the perfect square. Okay. One we don't use it lah, huh? One we can't use it. Okay, 4, 9. Okay, come on. Continue. Okay, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Okay, 6 times 6 is 36 and continue. Okay, so all these 4, 9, 16, 25, 36, we call it perfect square. Okay, so when you do these questions, you got to very sensitive with the perfect square. Okay, we come back here. Okay, just now the example from this website is square root of 8. Okay, so if you have a list of a perfect square at the side, you have a 4, 9, 4, 25, 36, and etc. Okay, so you got to very sensitive with it. Okay, see any of the perfect square is the factor of this or not. Okay, here is 8 lah, huh? Means you see any of the perfect square is a factor of is a factor for 8 or not. Okay, so you spot this one. Okay, 4. Okay, so 4 times 2 you got 8. This is how you start to with the simplifying. Okay, we go back to the website. 4 by 2. Okay, why you need the perfect square? Because this is square root. Okay, this one is the other way around of the law one. Just the law one saying that square root of A times square root of B is square root A times B. Okay, so now the other way around, square root of A times B, you can split them, become square root of A times square root of B. Okay, therefore, this is square root of 4, you can write it as, you can simplify it and you get 2. Therefore, your answer is 2 square root of 2. Okay. Maybe I repeat here because I cannot write there. Okay, so you see this one now I'm using this. Okay, just now your law A, but the other way around. Okay, so separate this. Okay, and then this you can simplify, become 2. Okay, 2 times the square root of 2, you can write 2 square root of 2. Okay, so after simplifying square root of 8, you will get this answer. Okay, this is the important parts that you're going to learn in this subtopic. Okay, we can continue. Okay, square root of 9. Square root of 9, you get 3. Square root of 10 cannot. Then square root of 11 cannot. Square root of 12, again. Okay, the 4 is a factor of 12. So you write the 12 as a 4 times 3. Okay, then and etc. Okay. Okay, we try the square root of 90. Okay, we'll come back to textbook. Okay, square root of 90. Okay, check the perfect square list. Okay, you know that 9. Okay, 9 is the factor of the 90. Okay, so you write the square root of 90 as a 9 times 10. Okay, then separate them out. Square root of 9 times square root of 10. Okay, then this part you can simplify it, become 3. Therefore, your answer is 3 square root of 10. Okay. Okay, look at this example. You see the how they ask the questions. Okay, write square root of 18 in the form of a square root of b, where a and b are integer and a is the largest value. Always a student, they're confused with this. They don't understand what's the meaning of a is the largest value. Means whatever you can take out, you got to take out. Okay, you can't you know, left some balance with the b. You got to take out whatever the perfect square you can, okay, to make it the a be the largest value. This is the meaning of. Okay, so now you see 18. Okay, 18. So what the perfect square is the factor of 18 is 9 lor. Okay, so it's 9 times 2. Then the square root of 9 you can write it as 3. So the answer is 3 square root 2. Okay, here the box you see, 9 is the largest perfect square number and a factor of 18. This is what you're going to find. Okay, this part. Okay. Okay, so this one you can do as your homework. Okay, and then question 2 as well. Okay, same thing. They want a is the largest value. Okay. Why you say that? Maybe I give one example. Okay, I take out, but I didn't take out all. Let me see. 108. Is it 108? Let me see. 108 divided by 4. 27. 9. Okay. Example this 108. Okay. Let's say 108. 4 is the factor. Call my calculator for a while. Okay, you see 108. Okay, let's say I know 4. 4 is the factor. Okay, so 4 times 27. Okay, 4 perfect square 27 Okay, so 4 and then 27. Okay, and then square root of 4 is 2. Okay, so I write my answer is 227. But this is not the answer they want. Why? Because the 27, you still can write it as 9 times 3. Perfect square. 9 is perfect square. Okay, so the A here, the 2 here is not the largest yet. This is the meaning. Okay, so here you cannot continue with 9 times 3. Okay, and then again 9 and then 3. Okay, then this is 3. Okay, so 6 square root of 3. Now the A, the 6 here is the largest. Okay, if you know, okay, one shot actually you can write it as 36 times what? 108. 108 divided by 36. That's what you got to try now, Okay, 3. Okay, so 36 and then 3. So 6 square root of 3. This is the answer. Okay, but it's not wrong if you use 2 times. You do it 2 times, it's okay still. Okay, but this is not the final answer. Okay, you got to continue. This is the final answer. Okay, now this is the meaning of the A is the largest value. Okay. Okay, what's the time now? 8:08. Okay, I still can show you a few more example. Okay, go down. Look at this. Okay, simplify the following expressions. Okay, how to simplify this? Okay, do times first, only do plus. Okay, so for this, you've got to do times first, then only do plus. Okay, so this one, your law number 1. Okay, you combine this. Okay, then you get square root of 6. Okay, square root of 6 plus square root of 6, you get 2 square root of 6. This part, I don't know whether you okay or not. Let's say the square root of 6 is a A. Okay, square root of 6 is another A. So what's your answer? 2A lor. So it's same as this. Square root of 6 plus square root of 6 is 2 square root of 6 lor. Okay, look at B. Okay, how to do this? This one, because of this and this, if you times, you can simplify it. Okay, so you expand it. Okay, so 6 times square root of 7, and then minus square root of 7 times square root of 7. This one is the, just now I asked you to write square root of A times square root of A. Okay, your answer is A. So square root of 7 times square root of 7, your answer is 7. No? Okay, and then this one, nothing you can do already. So this one is your final answer. Okay, okay, look at C. Okay, how to do this? Square root of 18 minus 8. You, by looking at this, nothing you can be nothing can be done. Okay, so what you have to do is you got to simplify it first, like just now. You know, take out the perfect, take out the perfect square. Okay, write in the form of the A square root of B, where the A is the largest value. Okay, same like the previous exercise. Okay, so here 18, you can write it as 9 times 2, where 9 is the perfect square. 8 is, you can write it as a 4 times 2, and then 4 is the perfect square. Okay, then separate them. So the square root of 9, you get 3, and then square root of 4, you get 2. Okay, now 3 square root of 2 minus 2 square root of 2. This one is same like just now, this one. So you can think of a 3A minus 2A lor. The answer is 1A lor. So therefore, the answer is square root of 2. Okay, or they do in this way, you see. Okay, they factor out square root of 2, and then inside the bracket is a 3 minus 2, also can. Okay, okay, look at this part D. Okay, part D, you got 2 bracket here. Okay, inside is an expressions. Okay, you have a plus here, so you got to expand it term by term. Okay, expand it term by term. Okay, so the first one, 6 times 1. Okay, 6 times 1. Then after that, first term times the second term, 6 times 3 square root of 2. Okay, next, second term times with the first term, and then last, second term times with the second term, 2 square root of 2 times 3 square root of 2. Okay, then do one by one. 6 times 1 is 6. Okay, this one, 6 and the 3 combined. Okay, 6 times 3, 18 square root of 2. Okay, this one, 1, nothing. Okay, so 2 square root of 2. Okay, this one how? Okay, 2 times 3. And then this one uses this law again. Okay, so it's 2 and then times 3. And then square root 2 times square root 2, you get 2. Okay, 3 times 2, 6. 6 times 2, 12. This is how you get 12 here. Okay, after that, number with the number combined. So you get 18. And then this one with the third one, combined. 18 plus 2, so 20 square root 2. Okay. Okay, next example. Okay, simplify each of the following in form of A square root B. Okay, so same thing. Okay, this 27. Okay, you can write it as a perfect square, as a one of the factor. Okay, so the perfect square that you can use here is 9. Okay, so this is square root of 9, you get 3. Okay, so 4 combined with this 3, so 4 times 3 is 12. Okay, the square root of 3, nothing can be done already. So you just write back the square root of 3. Okay, next 2, 4, 3. Okay, 2, 4, 3. Okay, 81. The perfect square is the factor. Okay, so square root of 81 is 9. Okay, then the 7 and 9 combined. 7 times 9 is 63. Same thing, square root of 3. Just leave it. Okay, 75. 25 as the perfect square, as a factor of it. Okay, then the square root of 25, you get 5. 5 times 5 here, you get 25. Then square root of 3. Okay, you look at this 3 example. Okay, we continue here. Okay, these three example has a square root of 3 as the irrational factor. Okay, means they have the same factor here, square root of 3, square root of 3, and square root of 3. And then this factor is an irrational. Okay, therefore, these three expressions are known as similar set. One more term, you need to learn, okay, write in your notes, what is the meaning of similar set. Maybe got no how to say definition of it, you just give example. Okay, similar set, you can give these three example. This one is, we call it similar set. Okay, then number that do not contain a similar irrational factor are known as not similar set. Okay, for example, the set of the expression, this one you can write also, not similar set. Okay, and then this is the example. Okay, here you see this is a square root of 3, this is a cube root of 3, this is a square root of 6, this is a surd 3 order 4, all are different surd, so they got not no similar surd. Okay, look at this example. Determine whether the set of the expressions, these three, are similar surd or not similar surd. Okay, by looking at this, it look like not similar law, but not yet, because this one I think can simplify, this one can simplify. Okay, so simplify first, okay, before you make the conclusion whether similar or not. Okay, so 12 you can use 4 by 3. Okay, then square root of 4 is 2. Okay, so this is 8 square root of 3 after simplifying. Okay, then 18 you can use 9 times 2. Square root of 9 is 3. So this one after simplifying is 15 square root 2. This one nothing can be done already. So 5 square root 6. You see, square root 3, square root 2, square root 6. Okay, therefore, okay, not similar set. There the conclusion that you can make, not similar set. Okay, so another homework for you. Okay, although you will see, today like a lot of homework, but all quite simple one, and then I think you can do it very fast if you can understand. Okay. Okay, I think that's all for today. I can dismiss you early a bit. Okay, I don't want to continue the other one. And then today is what? Wednesday, huh? Thursday, Friday, I got no class with you, lor. Means happy holiday already, lor. Okay, selamat hari raya already, lor. Okay, then after the hari raya, then 2 weeks again we will have online classes lah before our midterm holiday for another 2 weeks, huh? Okay, so after the 1 week, please remember come back for our online classes. Okay, any questions to ask?
Teacher, do you have to do 4.5?
Sorry, do I have what?
Do we have to do 4.5?
4.5, let me see. 4.5, yes, 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 4.5. Okay, I repeat today homework. Start with the 4.3. 4.3 because yesterday we only did question 2. So 4.3, you do question 1, and then continue 4.4. Okay, and then 4.5. Okay, and then 4.6. Okay, that's all. Okay, not Emily? Okay.
Teacher, how about the notes just now you mentioned? You take the blue box.
Which one? Blue. Which page?
I don't have textbook. Wait.
Oh, you don't have textbook. Okay, wait. Blue box. Blue box. Whatever I say, you write in notes. Then you write in notes, But you don't have textbook, means to replay this video, lor.
Okay.
Same thing, your style. You how to say? You follow your own style. How you want to make your notes. I think you mean this one, law 1, law 2, Okay, and then this one.
Yeah, I mean this one.
You replay the video and then you see whatever you need. Okay, you write down as your notes. Okay.
Okay.
Any more questions? Bye. Okay, if no questions, then I will stop recording. Wait for a while, I take attendance.